And it's Mr. Rops.
And Mrs. Flynn, and we are here today to talk about some double angle identities.
All right. And here are two angle identities, which you'll probably see a podcast, a theory on where they come about. But they are in your formula book, thank goodness, because so you don't have to memorize them, but you should be familiar with them and recognize when they come to be needed. Okay, so here's an example coming from November 2002 exam, once upon a time. We're told that sine of theta is 1/3. Well, and theta is an acute angle, which means it's in the first quadrant. We don't have to worry about positive and negatives, it's just always positive. We want to find the exact value. Well, if I have the first quadrant, I know theta is here. This is theta.
Then
so
we can plug in our values.
Right, so
if
this
it's
is
sine.
Right, opposite hypotenuse. And this is, we'll call it x. Now, I'm not putting it on the unit circle, I'm just putting it in the first quadrant. So if I want to find cosine, I need to find this x value. Doing this, I can do Pythagorean Theorem. So I can say x squared plus 1 squared equals 3 squared.
All right, so x squared equals 8.
8. And so,
square root.
Right, we get plus or minus. Is it going to be both, or this time we can just say positive? So we'll root 8. Which is 2 root 2. Now, we know this distance is 2 root 2. So if I want to do a part says the cosine of theta, well, adjacent over hypotenuse.
Easy enough.
Easy enough. To do cosine of 2 theta, well, now I need to use one of my identities. And I can choose. There's 3 to choose from. This one, or that one. It doesn't really matter which one I use.
Yeah, whichever one's appropriate, I guess.
Yeah.
Best.
We're given the sine value. So if we made a mistake doing cosine, so let's use this one. 1 minus 2 sine squared. So I know it's equal to 1 minus 2 sine squared theta. I'm going to plug in my values. I know this is, sine is 1/3 squared. So if I just come along and do some algebra on there, I get 1, 2, this is 1/9.
So 1 minus 2/9 is 7/9.
Oh, good, thank you. I had this pause and think. 7/9 we have. So there's B. Same kind of thing works for C part. Come here, computer.
So it's sine 2 theta.
All right.
We can go back and look at our double angles.
Right.
Identities.
Right. And if double angle identity say sine is 2 sine theta cos theta. So 2 sine theta cos theta. We plug our values in. Well, that's 2 sine theta is 1/3. And we times 7. No, hold on.
No, what was our cosine? Oh, right here. 2 square root of 2 over 3.
So 2 1/3 2 root 2 over 3. And so I multiply the top. I get 4 root 2
and 9 in the bottom.
Over 9. All right. Let's do one more problem here. Now we're looking for alpha being acute. And we have 2 cos alpha equals 3/4. We want to find cos alpha and sine alpha. Well, I know that cosine 2 alpha equals 1 minus 2 sine squared alpha.
All right.
Well, if 2 alpha is this, let's just plug it in and solve for sine.
3/4 equals 1 minus 2 sine squared alpha.
Right. And you should probably pause and see if you can solve this yourself.
Bring our 1 over.
And so I get 3/4 minus 1 equals minus 2 sine squared x.
And that is negative 1/4.
Oh, thank you. Equals to minus 2 sine squared.
Just get rid of those negatives and makes it.
Yes.
And divide by 2.
So I get 1/8 is equal to sine squared. And I square root.
Plus or minus.
And so I get sine equal to plus or minus 1 over, well, this is 2 root 2. Now let's think about where we're told alpha is acute. If alpha is acute, that means it's in the first quadrant. Oh, I changed my alpha to x's. That's okay. So it has to be the positive value. So sine of alpha has to be 1 over 2 root 2.
Now cosine.
Do the cosine one. Well, we're going to do a lot of the same. If we just take it, come on, and we go cos 2 theta equals 2 cos, we make it alpha since we're dealing with alpha, 2 cos squared alpha minus 1. I think that's right. Let me look at our formula, and that is the correct one. And so now if we come down here, cosine, what was cosine 2 alpha? Cosine 2 alpha was 3/4 from the question. Did I remember that correctly?
I have to look again.
Oh, it says
yes, 3/4.
3/4. So this is 3/4.
That equals 2 cosine squared alpha minus 1. Add 1 to both sides. So we get 7. I'm jumping.
No, that's okay. Well, I had it written. I'll just keep on going. Plus 1 equals 2 cos squared alpha. So I get 7, as you said.
7/4.
Slow down, page. 7/4 equals 2 cos squared.
Divide by 2, take half of that.
So I get 7/8 equals cos squared alpha.
And last step.
Square root.
Plus or minus.
We know it's in the first quadrant again,
So
same as before, so it's positive. And so cosine alpha equals root 7 over 8.
Or we could,
say root 7 over 2 root 2.
Don't know if that's
I don't know if that's necessary. Let's just leave it as this. The IB doesn't care if you rationalize or not, but they do care. You have to recognize things that are rationalized and know if that's the right, same as what you have. All right, that should be good. We'll do another example in another podcast.